Hello, so we are going to be talking about how to use a discriminant to find a constant in a quadratic. So it says, what are the values of a constant k such that the equation x squared plus 4kx plus 8 equals 0 has exactly no real solutions? So if it has no real solutions, that's talking about the discriminant. And if it doesn't have any real solutions, that means they must be imaginary, which would mean the discriminant, which is b squared minus 4ac, must be less than 0. So our goal is to find a value of k that makes this true. So in order for us to do that, we have to look at our equation and see what a, b, and c are and substitute them in. Since our equation is already in standard form, we can easily see that a is 1, our b value is 4k, it's the stuff in front of the x, and our c value is a positive 8. So from here we can substitute them into our equation. So that's going to look like 4k squared b squared minus 4 times a times c is less than 0. When you do 4k squared, 4k times 4k, that gives you 16k squared minus 32 is less than 0. Now here we don't typically solve quadratics with an inequality, so in order for us to solve this, we set this equal to 0 and say, well, once we figure out if it's equal to 0 or where it is equal to 0, then we can easily test to see which part of our which region is going to allow us to make this be a true statement. So we're going to solve 16k squared minus 32 equals 0. We solve this normally, like we normally would, by adding 32. So we'll have 16k squared equals 32. We divide by 16, divide by 16. We'll have k squared equals 2. Get k by itself by square rooting. So we'll have k equals plus or minus the square root of 2. Now this is not our final answer because this is when it equals 0. But we want to see where it is less than 0. In order to do that, we need to take these points and visualize them on a number line. So negative square root of 2 and positive square root of 2. Now, since this is a parabola, we know that it's a quadratic. It either means that it is less than 0 on the inside, or it's less than 0 on the outside. So we test a value to see. An easy value to always test is 0, which happens to be in between these 2 points. So we're going to test, what if our k value equals 0? Would it make our equation less than 0? So let's see. We substitute it in. We substitute 0 in for k here. When you do that, you'll get 0 squared times 16 is 0, so you'll get negative 32 is less than 0. You notice that's a true statement, which that is good, because that means in between negative square root of 2 and square root of 2, any value within that would make this statement true. What that means for us is that any number between these two validates the statement. So we have to write this in interval notation to show like 0.5 or negative 0.2. All of those would work, any of those values. So how we write it is from negative square root of 2, comma 2. And we use parentheses because it's not less than or equal to or greater than or equal to. So any number in between those two values would make this statement true, which would give it no real solutions. Okay, let's try one more. It says, for what value of m does the equation mx squared plus 8x equal 4 have exactly one solution? If it only has one solution, that means our discriminant is equal to 0, right? If it has one real solution, it's equal to 0. So taking a look at our equation, we need our a, b, and c, but it's not in standard form, which means we have to subtract 4 first. When we do that, we'll get mx squared plus 8x minus 4 equals 0. And from there we know our A value is m, our B value is 8, and our C value is -4. So when we substitute that into our equation, we'll have 8 squared minus 4 times A, which is m, times C, which is -4, is equal to 0. From here, we'll have 64, and then -4 times -4 is a positive 16m equals 0. And we're just solving for m to get m by itself. This time it's already equal to 0, so we can solve it like we normally would. We can subtract 64. So we'd have 16m equals -64. Then divide by 16 and divide by 16. So m would equal -4. Since it's already equal to 4, that means this is our final answer. We don't have to do any shading. If we were to substitute a -4 into our equation, that would make it have only one solution. Okay, something I forgot to mention that I would like to about this problem up above, that we substituted 0 in for k, and we got it in between. It was true for 0. But let's say it wasn't true. Let's say we substituted it in and we got a false statement. If it was false, what that would mean is that we would have to shade what's out here on the outside. When it's on the outside, what that means is our interval is going to be -infinity to -2. All the numbers to the left of -2. And then you'll have all the numbers to the right of √2. So √2 to infinity. And in math, we use a symbol called union. To dictate that you are combining these two intervals. So if it was false, this is what you'd have to write if you are including both of the outside intervals. Okay, I hope that helps. Email me with any questions.